Hey everyone, welcome back. In this episode, we are deep diving into memorization and caching, concept that can literally make your code 10x faster. If you are preparing for JavaScript interview or you want to understand how framework, so grab a notebook. We will learn what is memorization, why it is used, how it works internally, real world implementation, and how it connect to closures. Let's start with the concept. Memorize simply means remembering the result of a function call. So here we have whatever input we will pass to a function, so that output should be stored. So next time when we'll give the same input, so it should get from the cache memory. It should not recompute again. In simple word, instead of doing same work again and again, we cache the result for the future use. Why memorization matters when we compute in expensive things? For an example, like filtering large data or sorting or computing high mathematical calculation. That time it will consume our to compute that thing. So instead of again and again doing the same thing and recompute, we can optimize here. So that's why memorize matters a lot. Like for example, like React also using behind the scenes use memo just to optimizing or memorizing these things. Let's take a factorial function example. If you see here, we have just a normal factorial function. We are just console.log what number we are calculating again and again. So console.log, here we are just printing with the 10 value. If you run this one, you can see here it was not optimizing actually. The same thing again and again it was doing, calculating for 10, 9, and that's why it took this much of time to calculate. So here if we use memorization, we can optimize here. Now we will implement our memorization. So let's comment this one, write a function called memorize factorial, and we will store the cache. We will take a cache and that cache will be empty object, and we will return a function whatever will be, that will be factorial. In factorial we'll take n number, whatever number we want to. Now we will check if it is there in the cache with the number whatever user want to calculate factorial. So we will return from cache, we will not calculate again. If it is not there, then what we will do, we'll here console.log that we are calculating for n whatever values we are doing, and const result equal to n1 or n into factorial n minus whatever the formula is there, we just place here. And we will store in the cache, the result, whatever result will be, then we will return the result. That's it. Now how we can call this one, let's take a very function const factorial, and here we can console.log fact. We want to calculate for 10 for twice. If you run now this one, you can see the first time 10, 10, 9, 8, 7 it was calculating, and then this value they given. And the second time when we call the same with same value, it was showing fetching from cache, and that is 10. For 10 value we want, and it is giving. It was not calculating again. So if we'll give here another different value, for an example 15 we are giving, so what it will happen? For the second time it will calculate. For the second time it will calculate for 15, 14, 13, 12, 11, 10. Because we have already till 10. That's why it will calculate from 11, 12, 13, 14, 15. So this is how we can optimize this. This basically works because of a closure. This inner function, whatever we have, that remember the reference even after execution. So that's why in the beginning only I mentioned. So memorizing is basically caching plus closure. Now this code is optimized for only factorial, but we can't use this code for something else. So now we will learn how to make a generic function that can memorize any pure function. So for that we will comment this one, and we will write a function called Memoize, and this memorize function will take as a callback as function, whatever function we want to give, and it will take a cache, and we will store in a new map, and we will return this one. We will return the function. We will take all the argument whatever user will pass, and we'll store in key, and this key JSON dot stringify the argument. And the second line we will check if cache has the same key what user want to do. Console.log cache hit for, and we will return cache.get key. That's it. If it is there already, like if you already computed the same thing, or we have whatever generalized function was there, if it is not there, then how we will do? Then console.log cache miss for const result equal to function whatever user give the function, and we will pass all the arguments. and we will again, now we will set in the cache with the key and the value, and that's it. After that we will return result. So now this is basically a generic memorize function. Now you can use wherever you wish to do. Now what we want to add two values, but that two values will add quickly, right? So just to simulate the delay, we will run a long values loop. Okay, and after that what we will do is we will call those things, like we'll call this memorize add. So here what we have done is we want to get addition of two values, but now if we'll run this one, you see the cache miss for 5 and 10 and it returned 15. And the first call, it took 110.125 millisecond. And the second time, and cache hit from 5 and 10 value, but it is taking very less time just to get from the cache. This is how you can optimize. This pattern used in many libraries like loaders or Memoize. So this is basically a generic function. You can pass whatever you wish to, maybe an API call or whatever. If you want to pass the API call tomorrow, you can pass from here also. So if the value is same in input, so it will not compute again. So this is how you can optimize your code. Then what limitation we have with Memoization? Use it very carefully. Don't memorize function with side effect. Don't use it for unique input every time. Clear cache when data becomes stale. Thanks for watching. If this video helped you, please hit the like button and subscribe to us for more deep knowledge.